I would now like to call in Geoffrey Biggs and Yadunand Vijay for their opening keynote. They'd be speaking about the state of open robotics in 2024. Over to you guys.
Right. Good morning, everybody. I am very, very happy to be here at last. I was hoping to be here last year, but my visa was not as cooperative as it could be. But this year, I made it. I'm really, really happy to be here. It's so great to see such a huge crowd at ROSCON India 2024. It's only the second time and already 900 people. You know, it's pretty much the same scale as ROSCON Global, so it's just an amazing turnout. So I'm very looking forward to a couple of wonderful days with all of you. So I'm just going to give a, it's not close enough, huh? Sorry. Hope you can all hear me now. I'm going to give a brief overview of the state of open robotics in 2024, and then I'll be handing over to my colleague Yadu, who is going to talk about the state of ROS and Gazebo and OpenRMF. So let's dive right in. So who am I? I am Geoffrey Biggs. I am the CTO of the Open Source Robotics Foundation. I've been involved in open source robotics for more than 20 years now. Doesn't really feel like that long, but yeah, I'm kind of an old guy now. I am also involved in running the local Japanese ROSCON, so I know how much effort the organizers have been putting in for the past year to get this conference together for all of you, and I'd like to really thank them for putting all that work in. So I'd like to start by introducing Open Robotics. Most of you know, I think, probably the name Open Robotics, but you probably don't know that much about who we really are. So Open Robotics is the Open Source Robotics Foundation, and we are a non-profit based in America, and our mission is to support open source robotics. We want to support the distribution of it, the development of it, the adoption of it in all fields where robotics are used. That includes in research, education, product development, anywhere where you can find a robot. We want our stuff to be there because we think open source is really the way to go. So we have three big projects. I think probably most of you know about ROS. It is, after all, why most of us are here, I think, ROSCON. So ROS is our robot operating system, and this is the core of everything we do in robotics. Everything we do is built on ROS in one way or another. And so it provides basically the framework that we use to build robots and robot services and robot products. We also have Gazebo, which is a robot simulator, possibly less well known, but still very important. This is what we use when we want to test our robots without breaking the real world or people first. You know, we put them on a simulator and we use that to make sure our software works. And so this simulator, it's all open source, freely available. There are assets for it available as well. And this allows us to integrate tightly with ROS and work with our ROS robotics and simulation first. And finally, OpenRMF, which I kind of figured most people probably wouldn't know that much about, but from what I'm hearing, it's actually very popular in India, which is great. OpenRMF is effectively a meta fleet manager. This is what we use to coordinate fleets of robots and also other things in the environment that they use, like charging points and elevators and automatic doors and so on, to allow them all to work together as one big system. And these are our three big projects that really form the core of everything that we do at Open Robotics and all open source robotics. So Open Robotics software, it's really used everywhere around the world. You'll see that there are almost no countries on that list that are grey, and these are just the ones that we have data for. And I'm very happy to see that aside from America and China, India is also one of the darkest colors on there. It's great to see so much ROS and OpenRMF and Gazebo usage in India, and that's really nice to see. But even just looking at the numbers, these are some impressive numbers for software that is produced by volunteers. You know, all of these numbers are done by people who have been volunteering to work together for the greater good, and it has enabled so much stuff. We know of at least 1,000 companies using ROS and Gazebo in their products. We have seen so many startup acquisitions over the past few years for companies based on open source robotics software. We don't actually hear the price of those most of the time because usually it's private, but the ones we do know of already add up to more than $4 billion. So there's a huge amount of potential here for everyone. And of course, because it's open source, all of you can be involved in all of this. There are so many different ways to get involved. You can contribute bug fixes and new features to it all. You can add and improve documentation. You know, if you try and use the documentation and you find a mistake or you find some information missing, you can go in and fix that and help the next person who comes along. And just even promoting open source robotics software in your company, in your research lab, in your university class, even at your high school, you know, this is a great way to spread open source robotics software. And the more it spreads, the more we all benefit. And in 2024, we've actually added a major new way for people to support open robotics and open source robotics software. And that is the Open Source Robotics Alliance. This is a new organization that we have set up to try and support and keep these projects sustainable long into the future. To explain what it is, I want to first set up some terminology because often these terms can be a bit confusing with how we use them. So Open Robotics is our brand name, effectively. It is not a legal organization name, it is a trademark brand name that we use as an umbrella term for all of the work we do at the Open Source Robotics Foundation. And the foundation is the not-for-profit, which acts as the legal steward of ROS and all its related projects. Underneath that, we have the Open Source Robotics Alliance, which is a program that we are running in order to provide technical governance and sustainable futures to these open source projects. And so effectively, the Open Source Robotics Alliance, or the OSRA, is a mixed membership and meritocratic association where people join as members. They pay a fee based on the type of member they're joining as, and then in return for paying for that, they get to take part in the governance of our projects. They provide the technical governance that helps decide how the project should develop, what they should focus on, what sort of policies they should have, and so on. And so this structure allows us to provide representation for all stakeholders of all types, companies, individuals, non-profit organizations, universities, and so on, and allows them to support the projects and their OSRF so that they exist long into the future. The reason we've done this is because previously Open Robotics Software Foundation has actually been around for about 12 years now, and previously we had what we call a benevolent dictator model for governance, which basically meant that Open Robotics decided how to do things and did the work, and everyone else used that and was happy. We want to move away from that. We want to move to a model where the community comes together and decides as a whole how to do things, how to develop things, how to use things. And that is what the OSRA is designed to allow. It's a much more traditional model of open source governance. We've seen it be very successful in many different ways around the world. So, for example, Debian project, Linux kernel, and so on, they all use this sort of model. And so this is how we're trying to move forward with the Open Source Robotics Foundation. And we launched this 8 months ago, and already we've had huge success. These are our platinum and our gold sponsors, and you'll see some very big names up there that you know. NVIDIA, for example, which I see has a big presence in India. We're very thankful for them. They were a platinum sponsor right out the gate. They really showed that they believe in the mission that we're doing, and we're really happy to have them on board. But many other names on there you'll see that you know. And this is just the platinum and gold sponsors. If you move into silver and associate and supporting organization, the number just keeps going up. And this is just 8 months in. You know, we've already got nearly 50 members, 50 commercial members in just 8 months. And so growth is stratospheric, and we're really, really happy to see this because we think it shows that open source robotics has a huge future and everyone wants it to succeed. So if you're interested, there's some resources there you can check out to learn about the Open Source Robotics Alliance, how you can be involved. And I'd like to stress that not just companies, but also individuals can join the Open Source Robotics Alliance and become members and help support the future of open source robotics software. And with that, I would like to turn over to my awesome colleague Yadu, who is going to talk to you about ROS Gazebo and OpenRMF. Thank you very much. Over to you. Thank you.
Thank you, Jeff. Namaskara, Bengaluru. My name is Yadunand. I'm a senior software engineer at Intrinsic and formerly at Open Robotics and colleagues with Jeff. And it's really my utmost honor to be here today to talk about or give you an overview of what's changed in ROS Gazebo and OpenRMF. I have the privilege of working on the project management committees of both the ROS2 and OpenRMF project, and have also served as the release lead or ROS boss for the 9th release of ROS2, Iron Irvini. So let's jump right in. All right, so here's a snapshot of recently released ROS distributions. In the bottom row, you can look at how the release process works. So typically, we develop and merge features into our rolling branches, and periodically, every May, we branch off from rolling and create these distro branches. So earlier this May, we created the Jazzy branch and released Jazzy as a ROS2 distribution. Next year, we'll be branching to create Kilted. On the top row, we have a snapshot of distributions that have been marked end of life. So every distribution typically has its number of years that it's supported for, and once the date passes, it's marked end of life, and this is what the distributions look like right now. Put your hands up if you're still using ROS1. All right, so this is particularly relevant to you guys. So ROS 1 is going to go end of life in 5 months. I know the slide says 7, but it's 5 now. It's coming soon. But there's plenty of ROS 2 distributions for you to switch to. Humble, Jazzy, and Rolling are some of the long-term supported releases at the moment. And we think now is the best time ever to switch to ROS 2. And it's not only us who believe so. If you look at community numbers, we've had over 70% of downloaded packages being just ROS 2 packages recently. When we look at overall ROS package numbers, we're seeing over 40 million downloads per month. So this is a true testament to how the community is adopting ROS 2, as well as the growth in the industry. All right, so now let's take a closer look at some of the new features that are part of the 10th release of ROS 2, which is Jazzy Jalisco. First and foremost, we've revamped our executor behaviors to provide a lot more performant nodes when you write ROS 2 applications. So the executor, for those of you who are unaware, is that part of the ROS node that deals with actually executing the callbacks that you register. So these could be callbacks from subscriptions, from services, or from timers, for example. And the executor is that entity that decides when to execute what based on what events happen. So we've revamped this, and it's a lot more performant now, so that's going to benefit all users right out of the box. We've also added tons of new features to RViz, our favorite robot visualizer. We now have the ability to filter TF frames based on regex expressions. You can visualize subscription rates for topics you're currently subscribed to. And we've now incorporated point cloud transport. So this is going to make visualizing and streaming point clouds to RViz, especially from large 3D LiDAR scans, a lot more efficient. I'm sure a lot of people are going to benefit from that. So with Iron, we introduced the concept of service introspection. This gave us the ability to monitor who's making requests and responses to ROS services. With Jazzy, we now have the ability to record and replay these services. And this is a feature that's been long awaited for in the community, and it's really going to help people debug their ROS 2 services. With Jazzy, we also have better Gazebo integration. So now you can simply install Gazebo packages by running this command that you should be familiar with already, apt install ROS Jazzy gzsim vendor. And the good part now, moving forward with closer integration between ROS and Gazebo, there's almost a one-to-one pairing of which Gazebo version to use with which ROS version. And most importantly, the core team spent considerable efforts working on an alternative middleware for ROS 2. So now we have RMW Zenoh, which is a feature-complete middleware built on top of the Zenoh protocol. But why did we work on RMW Zenoh? Well, over the years, we've heard a lot of complaints from the ROS community about issues discovering nodes and also sending large payloads over Wi-Fi and maybe bridge networks like VPNs or Docker containers. While DDS can be tuned to make a lot of these problems go away, it doesn't lead to a very good out-of-the-box experience. So one of our big focuses for the core team was to provide a much better out-of-the-box experience with Zenoh. I'm not going to go into too many details of RMW Zenoh. Our colleagues Angelo and Vivek have a brilliant talks coming up today and tomorrow to go into more details, so stay tuned for that. But I just want to highlight that we have this new middleware, RMW Zenoh. It's going to use TCP for transport and discovery. We're introducing this concept of a Zenoh router that's going to act as a broker for just discovery information, and once nodes are discovered, transport will happen peer-to-peer. And when you have multiple hosts that need to communicate with one another, we will simply bridge the two routers on the systems, and all of a sudden, discovery and transport is going to work as you expect. We've been exhaustively testing RMW Zenoh over common challenges we've heard from the community, mostly sending and receiving large data payloads over Wi-Fi or bridge networks. We even ran a demo where there was a TotalBot in my house in California, and Julien from France was sending commands remotely from Paris, all without any external VPNs needed. All right, so let's take a look at what's coming up in ROS 2. So the next release is going to be Kilted, coming out in May 2025. One of the main goals is to make RMW Zenoh a tier 1 middleware. And there are a few steps needed to get to this state. First and foremost, we need to make sure that all our core tests pass. We need to ensure there's security built in by means of access control, encryption, and authentication. And finally, we have to ensure that the package builds and distributes on Windows, because that's another tier 1 platform that we support. The second big piece of work we want to achieve is maybe migrating to Conda to manage dependencies on Windows. So dependency management on Windows has typically been a bit challenging, so we're hoping Conda can provide the infrastructure needed to make this a lot simpler. Apart from this, there's tons of other things on our roadmap. We're unsure how much time we'd have to get to this by Kilted, but we certainly want to make some progress towards these items. More importantly, redesigning our logging interfaces, as well as how we define services, as well as the ROS IDL pipeline. On top of that, we also want to make RCL-Pi more performant. So historically, RCL-Pi's performance has been not as good as CPP or some other client libraries, and we want to bring this up to same parity as these other better supported libraries. Apart from that, we have some other concepts we want to explore, like evolving messages. So this is the ability for you to change your message definition. Maybe you have a twist message, you add a header, it becomes a twist stamped, and your nodes that's used to subscribe to twist messages should still work with the new twist stamped messages that are published. So these are some ideas we're exploring, and we could use a lot of help with these. With that, I'm going to shift focus to everyone's favorite simulator, Gazebo. Can I get a show of hands if you're still using the old Gazebo? A lot of people. Okay. Gazebo Classic, or the old Gazebo, is going end of life next month. So there's very limited time for you to switch over. When you run Gz server, following next month, you'll be met with this warning notice that encourages you to migrate over to the new Gazebo, along with a link to some documentation to help you along the way. So we know the migration can be challenging, but the Gazebo team has gone above and beyond to help everyone migrate to the new Gazebo. This starts with documentation we have, our migration guides, to help you port your existing ROS packages to use the new Gazebo. Apart from this, we've also conducted several office hour sessions, and there may be a few more upcoming, where you can sit down with the Gazebo team and understand how best to migrate your packages. The Gazebo team has also directly supported the migration of simulations for existing frameworks in the ROS ecosystem, like Nav2. But you might be asking, why migrate? Simply put, the new Gazebo is just a lot better than Gazebo Classic. It's a lot more flexible, it's a lot more performant, has a much better rendering engine to get you that photorealism that you look for, and it supports a lot of other features from Dart and Bullet Featherstone, making your fidelity of your physics-based simulations just a lot more better. And overall, there's just better integration with ROS2 as well to provide a much more seamless experience. So there's plenty of reasons to migrate, and there's lots of resources out there to help you migrate. So we hope all of you here can switch over to the new Gazebo as soon as you can. And here's an overview of these new Gazebo versions I've been talking about. So there are 9 releases of Gazebo thus far, out of which 3 of them are still supported. So this is Fortress, Harmonic, and Ionic. And Ionic is really our latest release of Gazebo. This was released in September. It's a short-term release, and it'll be supported for 2 years. It's officially supported as a Tier 1 platform, Tier 1 software on Ubuntu 24.04, and it's going to be paired with ROS2 rolling, and eventually Kilted when that's released next year. Apart from Ubuntu 24.04, we also offer support on Mac OS and Windows 10 and Windows 11, along with WSL, and of course, ARM-based devices running Ubuntu. So with every Gazebo release, there's often a demo world that showcases some of the new features that are part of Gazebo. So this year, we have this really nice indoor restaurant type of environment, and we think this is going to be great for all your mobile robot simulations. More importantly, this space shows off some really cool features we've added to Gazebo, specifically auto deactivation and simplified collision meshes, which I'll get to in a moment. So let's talk about some big features we've introduced in Gazebo Ionic. First and foremost, something we all love to hear, improved performance. With the new Gazebo, we have much better rendering pipelines. It's going to make rendering a lot more efficient. We have better support or closer integration with the Bullet Featherstone physics engine, which allows us to do something called auto deactivation. What this means is that you might be running a really large simulation world. 1 or 2 entities in the world may not be moving, or maybe it's done moving, so there's no point running expensive computation there to calculate physics parameters. So it'll automatically deactivate some of the collision checks, some of the contact checks that the physics engine provides to overall increase your real-time factor. Another way to increase your real-time factor is to use simplified collision meshes. So now in our XML, in SD format, we provide some XML tags for you to quickly specify a way to automatically reduce the complexity of your meshes. So now, by just specifying this, your existing simulation worlds should automatically run a lot faster because your collision meshes are simplified. We've also added the support for dynamic materials by allowing users to change the translucency as well as the emissivity properties of materials. We can achieve really cool lighting effects, and this would allow users to create or model different kinds of lights from LEDs to fluorescent lights, etc., which again add to that photorealism that will be needed for simulators. Another cool feature is improving the performance of the ROS GZ bridge. By allowing users to now compose the GZ bridge with the GZ server process into the same application, we can now offer much more performant transport between GZ and ROS. And all of this is achieved through composition, and we provide launch actions now for you to compose these nodes very easily. Finally, we've overhauled the Follow Me feature in the new Gazebo, so users can now provide a lot more configuration parameters to tweak how the camera should follow objects to really capture some nice videos from your simulation. And last but certainly not the least, we've migrated our documentation to Sphinx, and we have dark mode, which I know everyone loves, so please go check out our documentation. And here's a quick overview of the tentative roadmap for Gazebo Jetty, which would be the next release. I say tentative because a lot of these are still being worked on, but one thing we know we need to do is migrate from Qt5 to Qt6. Qt5 has been marked end of life, and we don't plan to support both in the next version, so we would definitely migrate to Qt6, but a lot of the other items here are pending discussions. All right, now it's time to talk about OpenRMF. How many people here know about OpenRMF or have used it? That's a lot of people, like Jeff remarked earlier. So OpenRMF is a framework that we've developed to help different brands of robots share resources. So these resources could be spaces in your facility, like hallways. It could be infrastructure systems like doors, lifts, or just any kind of automation system you might have in your building. So the OpenRMF team is proud to announce that we also support the latest ROS 2 release, which is Jazzy, along with the latest Gazebo simulators, Harmonic as well as Ionic. We talked about this Ionic world, this indoor restaurant environment. So the OpenRMF team actually led the demo that we showcased along with this Gazebo world. We had this really cool demo of a robot that navigates around using Nav2, being able to pick up a delivery, pick up a Coke can as part of a delivery and drop it off somewhere else. So just to explain everything that's happening, we have a work cell with a robot arm that's controlled by MoveIt that does a pick and place operation. We have a Nav2 robot that autonomously navigates in space to this location. And we have OpenRMF really orchestrating all of this. It's orchestrating the robot traffic, moving the robot around, talking to the dispenser, getting the item, and just fulfilling the task. So it's a really powerful demo of bringing all these different pieces from the ROS ecosystem together. So I encourage everyone to check it out. And let's talk about some big features we've introduced in OpenRMF with the Jazzy release. There's two main features. The first and foremost is mutex groups. So with mutex groups, you can now specify a group of vertices of lanes that belong to a certain mutex group. And what this allows is exclusive access to these vertices or lanes for any robot that's currently on these vertices and lanes. So this kind of supersedes the traffic negotiation system, and it helps ensure that robots are able to share spaces that are really small and really tight. Another big feature we have is the reservation system. So this is the ability now for agents or robots to reserve certain resources in the facility. Oftentimes you might have 5 robots, but only 3 chargers. And how do you decide which robot gets assigned to which charger? This is something that the reservation system helps with. With the system, you can now ask for a reservation spot or a ticket, and other robots that also need similar reservation spots will be provided a temporary parking spot to kind of hang around with. Once the resource is available, those robots will be guided over to use the resource. So 2 really cool features. These are already being used in production environments, so I encourage you to try them out. And here's a look at the roadmap of OpenRMF. So historically, OpenRMF is really good for environments like shopping malls, maybe restaurants or airports where there's really large spaces and maybe multiple brands of robots that need to share them. But it's been tricky operating OpenRMF in really dense environments like warehouses, for example. So we plan to address some of these challenges with some developments I'll talk about in a moment. But the goal is to really make OpenRMF a generalized orchestration platform, so orchestrate activities among any heterogeneous set of agents. We could even extend this to large cities where we can orchestrate traffic lights with mobile robots if required. So one way we plan to do this is by implementing something called Bevy Impulse. So it's this new framework, we're calling it workflows, and the goal is to be able to define an arbitrary behavior that needs to happen by an arbitrary set of agents. So this is something we hope to achieve through workflows. It's written in Rust, and it's built off this game engine called Bevy that we use actively in the OpenRMF project. And what this will allow us to do is really improve the state of our multi-agent planning algorithms, as well as our simulation environments that will be needed to simulate really large robots, large cities, etc. We plan to showcase this by means of fleet adapters or upgrading the demos we already have in RMF demos. We also plan to offer integrations to existing interoperability standards such as VDA 5050 or the Mass Robotics Framework. And we also plan to introduce much closer integrations with NAV2. So if your robot's running NAV2, it should automatically be able to talk to OpenRMF, open doors, take lifts, etc. With that, I want to shift the tone of my presentation slightly from state of ROS to talk a bit more about the industry. So we've often heard that ROS is something meant for hobbyists or students and not something ready for production environments. Over the next few slides, I want to highlight some companies who are considered industry movers who are really doubling down on ROS and building products based off of it. First, we have LG. So this is a huge company that's releasing a smart home agent. So this is a social robot that they're planning to release to their developers, and it's completely based on ROS 2. They have a nice developer interface, which has a Blockly or Scratch-like UI that lets you program the behavior, but underneath each of these blocks is ROS 2. And they also provide an SDK that's native in ROS to help you build these blocks. So it's really great to see such a big company really doubling down on ROS 2 to ship a product to consumers. And on their developer website, they explicitly have a section on why they chose to work with ROS 2. So they're convinced that most robots that will be shipped this year and next year will be running ROS natively on it. And they just have confidence in the growing ecosystem that they're seeing around them. There's often been this gap with traditional automation systems like PLCs and field buses and the rest of the ROS 2 ecosystem. And it's really great to see some big players in this traditional automation space like Siemens and BMW put out bridges to talk between traditional PLCs as well as ROS 2 systems. So this was something that they announced at ROSCON this year. Something relevant we also saw was companies like Bosch and Stogel Robotics unveil something called Control-X. So this is going to be a development environment, a deployment environment that lets you ship your ROS 2 capabilities onto edge devices much easier. And these edge devices are going to be running in real time, so they would be able to control your robots and other devices in real time while talking ROS 2 to other traditional automation systems. Other companies doubling down on ROS is Intrinsic. So Intrinsic at ROSCON recently unveiled how we can bring in capabilities from the ROS ecosystem into your Intrinsic applications. So Intrinsic hopes to deploy robots on the cloud or make that process a lot easier. And now with this extension, there is the possibility to take ROS nodes and then run them on the cloud and be able to remotely monitor them, provide over-the-air updates, etc. Robot OEMs like Universal Robots is now talking about natively supporting ROS on their controllers. So their next version of their robot controller, Polyscope X, is going to offer the opportunity for you to directly send ROS data to it. Imagine publishing a joint trajectory message and having the robot move without requiring a ROS driver. So this is the confidence that OEMs have in ROS as well. And ROS is also great for a lot of early stage startups building products or creating businesses around the product. For example, Dextery and Polymath Robots are building autonomy stacks. Well, Dextery is building a robot to scan shelves in warehouses, and Polymath's building a generalized autonomous stack built on ROS. But they're both doing it in a way that pays forward to the ROS community. So they're engaging with organizations like Open Navigation to build features that are then open source for everyone to benefit off of. And these are some great ways that anyone can contribute back to ROS. And we hope some of these companies here can kind of inspire everyone here to build boldly with ROS and ship products out there for everyone to use. There's plenty of ways to get involved, so I urge everyone to take a quick picture of this slide. There's 3 different QR code images on it. The first one would point you to a documentation page that lets you get started with ROS. No issue is big or small. There are tickets for everyone to address. It could be a simple documentation change. Maybe you tried using a package and it wasn't easy to use, and then you figured out how to use it. Updating the README goes a long way. So there's many ways to give back, so please take a look at this link. The second link points you to a calendar. So all the projects within Open Robotics has a public calendar. So this is ROS, OpenRMF, and Gazebo. They might also be calendars from different working groups, like the real-time working group or the client library working group. So this is a great way for you to get exposed to what's happening, look at the discussions that are happening, and find out things that you can help out with. And last but certainly not the least, please consider joining the OSRA. Every dollar counts. And this is also possible for individuals like you and I to just join OSRA as well. With that, I'd like to thank you from the bottom of my heart for your time and attention. I hope this has been an informative presentation, and we're happy to take any questions.
Hi Geoffrey and Yadunand. Thanks a lot for this talk. It was very informative. My questions to Geoffrey. So now that you see a lot of defense industries picking up open source software and it being, a really huge industry now, so how do you see the ethics and morals that surround the open source community, not just ROS, but also the other ones? How do you think they'll be shaped, in the let's say the next decade? So would there be more restrictions or would there be more development?
Well, it's a tough question, right? Because it's open source, and that means that we can't say what anyone does with the source code. We can't say that you are not allowed to use it in this particular application. And so from that point of view, if someone wants to use it in a killer robot, we can't really stop them. And that's part of the license. That's how open source works, right? Because we don't know what people are going to try to do with the stuff. It might be bad, it might be good, but we don't know. And so we have to let them have that free reign. On the other hand, on a personal level, and also for the Open Robotics Software Foundation, I and the foundation both take a stance that we do not support robots being used in any unethical ways. So that includes, killer robots for the military. For example, we don't believe that is a good use of robotic technology. And I feel that everyone should think about their own personal ethics. And if you start a company, about the ethics of your company, and think about how you feel about what you're using the technology for, and whether you think that is ethically appropriate or not. And really, ultimately, it comes down to everyone doing what they think is right, and trying to take a good stance for the benefit of the whole, really. We can't say people can't use it, but we will not get involved effectively.
Hi. So thank you for the talk to both of you. Now, I'm a newbie at this space, in this ROS space, so correct me if I'm wrong. What I feel is that during the implementation process, there are multiple versions and there are multiple advantages, the new versions that you're releasing. But the adaptability in the real world application that I have to install and run it on a robot, that adaptability I feel is very slow compared to the versions and the features that are coming in. So how do you, what comments do you have on that, or how do you wish us to migrate when proper, I fail to find proper libraries or proper I hope you get it what I'm trying to mean.
Let me take it? Yeah. I'll add to it.
Okay. So migration, there are two aspects. The first is migrating from ROS 1 to ROS 2, or Gazebo Classic to New Gazebo. And both of those are big leaps because you're effectively migrating to an entirely different project. So that's really a massive undertaking, but it does need to be done before the end of life comes along, because then you lose all your support. You won't get any new patches coming in. But when you're looking at, say, going from ROS Humble to ROS Iron to ROS Jazzy, it almost always just works. There's no major changes. There are always going to be little additions. There may be API changes in the changelog that you have to take care of in one place or another, but mostly your software will just work. The main thing is that packages that you use that are provided by other people might not yet be provided in binaries for that new one, and so you might have to build those from source until they become available. And so when those packages become available as binaries for a new release of ROS, it depends on the person maintaining that package, because this is a group effort, right? And not everyone has the same amount of time. But in general, it's not actually that much of a major hurdle to go from one release to another. Anything?
Yeah, just to add to that, when we talk about core packages in ROS, there are essentially 300 or so packages, maybe dealing with publishing a message, subscribing to a message. So really the plumbing or the underlying infrastructure that's needed. But there's tons and thousands of packages on top of this that maybe you're relying on. So if you ever come across a situation where a package that you rely on doesn't have a migration journey, I would say ping the maintainers, and maybe if they're not responsive, consider forking it, consider being the one to migrate the packages. And then there's opportunities for your fork to be the official ROS2 version of this package, for example.
It's a great way to contribute.
Yeah. I think we have another question up there.
Hi, hi. My name is Raghu. I'm CEO of Art Park. It's been great bringing this to India, bringing ROSCON to India. What do you think we can do going forward from here, right? To really accelerate the ROSCON community and bring in more industry and startups. Just looking for big picture ideas on what could India do for the ROSCON movement.
I think that the best thing I would like to see is more contributions coming from India. I mean, I see there's 900 people here. There are so many companies doing robotics in India that I've just learned about just in the past day or two. And yet, on an international level, we very rarely see contributions coming in. We don't see documentation contributions or source code contributions. And it's very clear that there is plenty of talent in this country that can do this. And so I think starting to give back in that technical way would be really good to see, because I think it would really show the rest of the world that India is just as big as they are and just as important. And that really would help a lot for both India and the whole movement around the world, I think.
We would love to engage more closely and see how we can foster that, how we can make that happen, because
yeah, I mean,
perhaps
that is something,
some concrete steps we can
yeah,
take.
we would love to help out there, and I'd be happy to talk to you about that and try and figure out what we can do to encourage this. I mean, it varies a lot around the world. Some countries have a culture where people just do it, and some don't. Like I'm in Japan, and the Japanese do not contribute at all. And it's always been something I've struggled with. So, you know, we're always trying to fix it, and I think that really contributing is the way to put your community on the map.
Hey. Yeah, first of all, great work. Building ROS, like you have built like really cool building blocks for all of us to get started with. So good foundation there. But moving forward, I believe like if you want, you know, more robots around us, what is a mental model you would want us to imbibe? Because you work closely with, you know, developers as well as industry experts. What mental model do we imbibe to get our robots which we build to industry, like on the production level? And how can we use ROS on those lines and make it, you know, simpler? But because definitely ROS is used in industry, but I feel there is this gap between how we use it for our projects versus product. So what do you find those common patterns, those mental models which are followed by industry experts, which we can, you know, pick up and, you know, work on it? Yeah.
Yeah, I can go for that. Yeah, no, that's a good question. I think one thing that I've seen often is when we develop products, we're thinking more from the tech perspective of just getting the functionality to work, the feature to work, et cetera, and not really being mindful of what it takes to scale this or being able to deploy whatever software we are writing. And there's been a lot of great companies giving talks at ROSCON that define this exact journey. So they have a very deployment-first approach to their development, and that really helps them go quickly from a lab prototype to some kind of production-ready system. because their normal development workflow has CI, CD. They think about the cloud, they think about logging, a front-end dashboard, all of these things. And the tech or the core capability is just one small part of it. Like I remember in the talk from Dexery, they showed a snapshot of the different containers running on their actual robot. ROS is maybe one of maybe 20 containers running there. So there's a lot of other things that are needed in order to get a robot out into production. And I would say thinking about those things early on is really helpful. And anytime you're unsure, maybe Jeff and I don't have all the answers, but there is a brilliant portal or a web page called discourse.ros.org, and that's a great place to just ask questions. There's so many other people having similar thoughts, and getting a conversation going there is super easy, and I'm sure you'll find all the answers you need.
Hello. So I'm a faculty, I belong to Mahindra University. So when I teach this thing to students, if I ask students to install AutoCAD, they're able to install. If I ask students to install ANSYS, they're able to install. But when I ask them to go for ROS, from the beginning step till the last step, they're taking almost half a semester or more than a semester to do that. Okay, so is there any way that you can simplify that process so that we can make it more adaptable? In India, we are starting BTech in mechatronics, BTech in robotics, all those things we are starting, but those who do not have basic skills, they're struggling a lot to do this thing. So what can we do for that?
Should I take it? It's a tough question. I hope the infrastructure team was here, but no, I think it's a valid point, right? Because you have engineers in different domains like mechanical, electrical, maybe even environmental, who want to get started with robotics. And it's often a huge barrier to get started with Linux. You have to understand a new OS, then you have to understand all about networking, etc. So there is a bit of challenge there. What we've seen become really popular over the years are virtual environments or maybe containers to get any kind of operating system quickly set up with some kind of ROS backend. So I would say maybe look for other curriculums in the world. I'm sure there are other universities out there who are teaching using ROS. And from what I've seen in my limited experience, they're relying on containers to do it. So maybe that's a great way to get anyone or any computer set up with ROS in just a matter of minutes.
At the beginning, but after 10 lessons, I'm again deviating. So it is a kind of complete effort students have to make to do that.
Yeah, and perhaps this is something the documentation can improve as well.
Yes.
Right? So from your experience, you've had some challenges setting up maybe even containers. There is a section in our official documentation page getting started with containers. So maybe if you find some helpful tips there for your students, maybe a contribution there would help everyone.
Thank you.
Hello. My name is Swaraj. You mentioned the use of Rust and Bevy in your Open RMF roadmap.
Sorry, where are they?
How would you suggest the use of Rust or Bevy instead of C++ or Python in ROS? Like, what are the advantages that we can have using Rust?
Sorry, Suraj, can you raise your hand? I don't know.
Yeah, this side.
Oh, you're right behind the light, so I couldn't see you. Sorry, do you mind repeating your question again?
You mentioned the use of Bevy and Rust.
Yep.
So how would you suggest the use of this instead of your traditional C++ Python? What are the advantages of Rust in ROS?
Yeah, I mean, the advantages of Rust in ROS are really the advantages of Rust over C++ in any domain. Memory safety, compile time checks, much easier to write async or coroutines. So there's a lot of advantages there. And we feel like learning Rust also makes you a better programmer when you use C++ or C. You're more mindful of memory management, of lifetimes, etc. So the inherent advantages are just writing code or maybe moving faster without worrying too much about segmentation faults at runtime. So those are the general advantages, I would say. Yeah, so there's been several Rust client libraries that have been put out by the community. I know the OpenRMF team is doubling down on one of these packages called ROS2 Rust. And I believe it supports everything except for actions at this point. So if you're a good Rust programmer and if that's something you want to contribute, I think there's a lot of tickets waiting for you.
I know you guys have a lot of questions for Geoffrey and Yadunand. You can catch them offline to discuss, and I think you guys would also have a lot to talk with them. But unfortunately, we're running out of time, so I'll take a move to the next part of the agenda. But thank you so much, Geoffrey, and thank you so much, Yadunand, for taking through the entire journey, through the entire thing for us. Thank you.